mention like what Bisq is capable of. So I will go over like all those details, like all those points, like in a little detail with the help of the interface. That okay, this is how it looks like in this, and this is how we can do it. So so we'll start with we'll covering over in wildlife surveys and how AI can help in like come in and help over there. And then I'll go over the part of like an introduction to this interface. So how does that look like? Just like a familiarity with it. And then how you can use it. So basically like as Professor mentioned, for data storage or for visualization or for annotations, or if you want to do very AI-based analysis on your data. And then Connor will be going over a light demo, like a kind of theory part as well. Like we'll show like light demo step by step, and you guys are going to do that too. We'll try to make sure like everyone is able to reproduce that and like play around with that and become familiar with it. So starting with the why like about wildlife surveys and how AI or and this can help it over there. So population census, this is very critical now. And most of like time it is how it is done is either like there's an airplane that is flying through over the area, or people are manually visiting the locations, or in some cases there's a satellite imagery too. The amount of the data is like insanely big, and amount to process that data is almost like next to impossible if you have to manually go through every image. For example, even the data set that Jared introduced in the morning, so that has 11,000 images. And those are not small images. Each one of them is like 5,000 plus 8,000 pixels. So this is like, and this one, and this is a big data. And if you have to go and manually do everything, this is going to be a difficult task. So what we show over here, for example, this is a sample image. This is from the data set that Jerry mentioned. And you can see in this image, there is like a elephant that is clearly visible. And this is like an easier example. The task becomes much more difficult when there is a cluster of animals. When it comes to cattle or shoats, they're tiny too, like shoats, and then cattle, and they like stick very close to each other too, and they are not as big as elephants. So even like going there and manually counting those, there's like a different. So that's the like these are a few of the challenges. So like I mean managing such data is very difficult. Visualizing is another difficult problem. Then even if let's say I have a data, and then if you want to share like there's a group of people who want to work on it. So how you can share that data, or you can share the data or collaborate on it, multiple people can work on the same thing at the same time. Let's say like I'm like we have 11,000 images, and then I'm taking care of the first 100 and then taking on the second 100. So if there is a way we can have it at the same place, and then people can start like annotating them at the same time. So that is a very difficult thing too. And then another thing where like we can come like AI comes in picture is like identifying like very small objects. There's a chance that we might miss because human tend to do get tired too, and our brain do the same. Whereas like a rocket might be like a very it's just a bare rock and it looks like an animal, and we are so happy with animated rock. So there's a those possibilities too. And then yeah, and this all analysis is very labor intensive and it's difficult to verify. And another thing that I want to highlight over here is so sorry, so that I can get my slower because
yeah, just speak a little bit slower if you could.
Okay. Sure. Well, thank you for telling. So another important thing is, though there is a big research community which is working on developing those AI models, those are like as good as like useless unless you can reproduce them. And reproducing them on your end, even though like a trained expert, if let's say like I am working on a model that someone else have developed and they just have made their source code available. So it's going to even take me like a couple of days to a week to actually introduce it on my site so that I can even have the same results which he had. So that is like a very difficult like challenge over here too. And on top of that, you are in resources also, like because all the machine learning models they need like a significant amount of resources. The compute power is huge over there. And so where it so so this is where like this comes in picture. So it was developed at Vision Research Lab. The development started somewhere around 2000, I think early 2000, somewhere like 2005 or 4. And first it was built as like a tool for biomedical images, where there are multiple modality of images. And to have a same, like one ecosystem where you can have those. And also you can have like in the same ecosystem that can be shared across multiple people. So that's where like Bisq is like it's a cloud-based service. It's also open source, so you can have your own instance too. You can our source code is publicly available, and we have made our Docker containers available too. So it's as simple as you can download our Docker container and just spin it on your site. Though you're going to need a significant amount of compute on your site to actually do something with it. And another thing, there are like you can have custom and built-in machine learning modules. So a very good analogy Connor mentioned is like it's just imagine it's like a DVD player, and we're based on the DVD player, and your machine learning module is like the DVD player. You can have different type of DVDs and you can put it in, and you can do your things. So this is how like you can have like multiple AI-based model in the same framework, and then multiple people you can use it. Another powerful part of this is the visualization part. In total, there are almost 272 image file formats which exist out there, and this supports almost 250 plus of them. The ones I believe like, do not support are like proprietary or like few are used to new to. And then on top of that, if you want to export anything, so you can export the limit format is changed. So you can export data in any format from this. So this is this again coming very handy when it comes to like wildlife surveys data, which is the size is very huge too, and the problem is very different. So this is a sample, like a video of like how Bisq interface looks like. So we have hosted it from bisq2.bc.ucsb. All you have to do is open your Google Chrome browser and you just type in that in and it will load this web page for you. So this web page is, this is how it looks like. And over here, without logging in, you can explore like all the public data sets. So this is an example of a public data set, which is from my like a recent paper. I made it public so that people can see it. So without logging in, you can visualize your data set. This is an example of a hyperspectral data set. But for visualization purpose, I just show like RGB and like a 4-channel. So this is like a aerial imaging where detections are methane gas emissions from the ground. And you can smoothly like visualize them in this. And another thing is you can look at like applications. These are the possible applications. For example, for MARA, we have annotator, detector module, evaluation, with the report generation. And they are almost having 50 plus modules already have right now. So let's say like there are almost like 20 plus modules. Yeah. So you can look at those these are like AI-based modules and instrument testing. So to access one of those, any of those, you need to like log in and create an account. So in the interface and signing, you can just go as simple like register as a new user. There's a corresponding Google Doc form over here. So yeah, you can fill up that form, your email ID, your name, and the research organization you're working for, and the research field or other relevant information, and we'll create an account for you. The reason we did it, because thing is, there are like a good amount of compute resources which are running in the backend, and we don't want anyone to just access it without us knowing the credentials. So that's why we ensure that someone reach out to us first and then create an account. So I'll go ahead over here, just like since I have the access, so I'll just like log in over here. So this is how when you log in. So this is how your page is going to look like. So this is your account in this. And you can access over here what is relevant to you. And you can access the data which is shared to you and also which is public. There are some statistics available to you. Like these are generic statistics. For example, number of images that are uploaded daily, number of model analysis that are done on daily basis, on a monthly basis. Also, like there are total number of images which are available on the infrastructure right now. So these are like very relevant, but yeah. So we do actually have some statistics. And then on the UI, we have a bunch of different, as simple as you can upload either a file, but like a directory or a zip file or anything. You will just simply drag and drop convert. Download, you can export in any format. And then come to analysis. So these are like the list of modules that we have that you can get inside this. And these are just again, these are like those DVDs that you plug. And then when it comes to browsing, you can browse your data in any technology you want. So you can actually browse by data set, you can browse by file type, you can browse by even if it was last format changed, or there's something called as like max URL that is going to come in handy that you could go further. So here I'm showing an example of like browsing by data set. So all you have to do is you like click on the data set to show you all the data set available to your account, and also you can select if you want to see all the public data or the data shared specifically to you. So all you have to do is you can just use the slider and just show you this. You can sort out the data set too, on like this is in the same interface based on the name of the data set, the time it was created, or the time it was last modified. So that all is there. And then going back, so so next part is so we're going over the detail of it. So the first part I showed like as simple as you log into the interface, you want to put some of your data. So you just click on the upload button and you can even like select a file or folder or any type of file, and just simple as drag and drop. And whatever is happening is this is the dummy data set that we have shared via Google Drive with all you, so yeah, all of you. So we're gonna do like a demo so that you can also reproduce it on your side. So all you have to do is do a drag and drop. And what it does, it uploads the data and then it ingests the data. And by ingestion over here means it keeps the image separately and it takes all the metadata from the image, the information, and keeps that in a separate tab. So that that comes in handy because if you are, let's say, looking for something in your whole data set, browsing through all the images might take more time. So if you want to find out that thing quickly, so you like whatever you're looking for is the information relevant to the metadata, you can easily quickly query that. So so this is like a sample of like the data that I uploaded. So it's just a visualization. So I drag and drop the metadata, like sorry, drag and drop the data folder over there, uploaded it, and you can just directly visualize it. So another thing over here is, so this is like a recent new addition to this. And over here, this is an example of if your, so thing is, if your data is very huge in size, you cannot wait and like upload everything to a web interface. And that too when the internet is like also, let's say, like slower or less reliable, and the latency is very high. So in that cases, we support integration with like covers. And this is basically in University of Arizona service and integrated in this infrastructure. All you have to do is over there's like a UI for it, and you can upload your data using that interface. First of all, using that interface to Bisq just by like a click of a button, and it works very reliably in case of when the network is unreliable and the latency is super high. Another useful, beneficial part of iRoadset is like if we have sufficient expertise, you don't have to upload your data to this. If you have, let's say, 1 terabyte of data or like a couple hundred terabytes of data, so you can run like a iRoad server on your site and mount that directly on this. So your data will be on your site too. We are not replicating it anywhere, and you can still do processing through this on that data. So you can run those analysis model from this, access the data from there, and then get your inference. So this is like a good use case that we got from University of Arizona, where they have like a drone which flies into the field and like at different times, and where it flies where the bandwidth is super low and the latency is super high. So in that case, they just have like a simple UI interface where it uploads the data on the like I mean whenever there's the internet available and latency issue there. So the next part is to visualize your data and the data set. Okay, so in this one, so let's say the data that you have uploaded. So this is our data set that was shared with us. These are total like 1,000 images, annotated images we uploaded inside this. And over here, this is not a small image. This is 5,000 plus 8,000 pixels, and it is like this loads it and visualize it very like smoothly. And you can like zoom into the image, look at the annotations, You can turn off and turn on the annotations too. So you can like clearly look at the animals over there. And yeah, so yeah, these are the annotations. Yeah, and back to it. And another thing over here is if you like instead if you have a large amount of images in your data set, instead of like opening them individually one by one, and that in different tabs, so you can browse through each images in a sequential manner. So there's like these are different type of visualizer inside this. So how you want to visualize like in the thumbnails or like the in the list format, or you can open the images along with the metadata, and then you can just like browse through each of the images. So this is like that's new inside this to visualize your data or like the whole data set too. And then annotate data. So this is an example of the Prairie Dog project that we have been working with Smithsonian locally. So this is like not a single image. These are different types of images stitched together, and it covers the whole landscape. There were the I think it was like drone images wherever it flew over there. So this whole image is snapped together and like registered together. It is 100,000 cross 100,000 images. And you can very smoothly upload and visualize this image inside of this. And then on the same image, you can like zoom in and like annotate like the relevant region which is important to you. For example, over here, we are annotating the bounding boxes on the burrows where the prairie dogs actually usually hides. So then next I'm going to go over different type of annotations that are there inside this. So how you can annotate your data. So the first one is box annotation that everyone is aware of. It's very simple and standard. So wherever you see the object of interest, all you have to do is you go to the graphical metadata and you click on this pencil type button. Or you're going to go have like a live demo too, and you can to do that too. And all you have to do is you have to just draw a square over there, and it will like add those in your like list. You can actually provide a name to your classes over here. It's super easy, and then keep on drawing boxes on the relevant. You click on the class, keep on drawing boxes on the relevant object. Another one is this is very common, like for example, point annotations. This is just like providing a dot. So exactly the same method. There's you click on that pencil button, edit pencil like button, and then you select the point over there. So if you see these are the type of annotations which are there. You select the point over there and you just drop it. So it will just save the allocated values. So the X and Y points. Then another thing is polygon. So that is these are like slightly more detailed annotations where you actually draw a segmentation mask on the whole object of interest. Let's say the object of interest is an elephant. Instead of drawing a boxer, I want to mark the exact boundary of the whole elephant. So that is called as like a segmentation or like you draw a polygon. So this is also your, so you select a polygon and you can actually create a polygon inside this. And then line annotations. This is like less used, but also, yeah, this is still there. You can just draw lines inside this. And like these all are stored. And these are another thing on top of it. All of these are like once you have created this, all of these are editable. So you can delete the annotations, you can edit the annotations on this. So now we're going to the next part, that is like download. So once you have done everything, so let's say you uploaded your data sample and then you annotated your data like images, and you want to download it. So this provides an export in like any format. So either you can export the data in your original format where it was uploaded, downloaded. Oh,
Excuse me. I downloaded. I downloaded the program, but
one second. I think the GIF for the slide got messed up. Sorry. So in this one, you are actually downloading the data, the images that you have, and along with that, the annotations, that is the bounding boxes or points that you have drawn in your image. So it will download both of them separately. So as Professor mentioned, your image stays intact. There are no changes to your original data. Everything else stays separately. So in our case, like once you hit the download, so it will download your images separately in a folder. Like everything comes as a zip. And your annotations, that is your points per boxes, they are downloaded as an XML where it says the class. So
these are the satellite images, so they what image?
it's almost any kind of images that you're looking at. So this is the example of the drone images that we have from the project. So for again images. But you can download any type of data that you have inside this. Even if there is a data sample that is not parsable, like I mean, it's something totally unique that nobody has ever seen, you can still upload that data to this, and this will not like keep that in its original form too. It will not damage the data. It will keep that as a block. The only limitations are going to be you will not be able to visualize inside. So, and then once you can download it or you can share it with anyone, and they can download it in that original form. So, and then now the most interesting part that is doing analytics on. So let's say you have your like uploading all your images, and now you want to do any kind of like AI analysis that is detecting something, like detecting any object of interest. So over there, we provide like a list of modules. So where this is an example, so it's the demo data set that we uploaded. Let's say these are the 4 images, and I wanted to do detection on it. So I click on the analysis tab, and I select the Mara Cosine module. Okay, this is the group of modules for it, and I'll do like a detections on it. So to do detection, so I select the data set that is there, then select the which module that I want to use to do inference on. So like ways of that. This is like a terminology. You can ignore that as of now. So you just call it like a learned AI model. We select that and we give a name of it. So whatever annotations or like whatever the boxes it's going to generate. So you keep them all of them together in the folder. So you give a name to that folder. And as simple as you just hit run. That's it. You just do like AI-based analysis with a click of a button. And right now, what it is doing is it is processing the images to you know,
You're hard to hear. That's all. So like if you can just speak slower. It's a lot of information. But I think the important point here is that you're also going to do a live demo. We're going to do that together.
yeah.
So the pieces you've shown so far are collecting some kind of digital imagery.
Yeah.
In this case, aerial survey imagery. You've shown that you can upload it to this, right? Then you can do your annotations using multiple different ways to do it based on what you're trying to identify. And then with seemingly a push of a button, you can apply an AI model and go through the remainder of images.
So yeah, so Jared explained. So this is what is happening right now. Also, can I have that one near to me? I guess maybe that will be helpful. It will be more.
Yeah.
Yes.
Put this one here, because that's the one that's connected.
Oh, is it better now? Can you hear me? Like, is the voice
Much
clear?
better. Much better.
Thank you so much. We brought the mic closer to us.
Yeah, it is very clear now.
Oh, we should have done that from starting. All right, I'll do it. Try it again. So over here, we are showing an example of. Thanks. Sorry, the laptop is not responding now. Oh, it crashed. 1 second, we'll try to recover it. PowerPoint crashed. I think we forget this is what Professor Manu
Okay, yeah.
said.
So it's just refreshing.
Stop sharing and share again. Awesome. So in this slide, we are showing the analysis that you can run on BISC. So this is a sample where where the data set that we uploaded. So we select the data and then we select from the categories of modules. So over here, this is the one sample. Like these are Masai Mara modules that we built. One is for detection, report generation, or evaluation. So your data set is there. Then over here, when you click on this button, so over here you're selecting the pre-trained AI module which is capable of doing those detections. So we select that, and then in parameters we give the name of the folder where all your outputs will be saved, so that like it's easy to recognize for you. And all you have to do is you have to hit the start button, and that's all. So that's your one-click analysis. So over here, what it is doing is it is downloading the corresponding Docker container, and then taking those images and then running analysis on them one by one. And analysis over here, by that I mean is it is actually doing like a detections, bounding box detection on one of with animal detection in each one of them one by one. So once we have done the analysis, so now if you want to look at your results, so all we're going to go back to the same data set on which we did the analysis. And again, here we are just so here we are just visualizing it. So nothing has happened to your original data. Your original data is still intact. So over here, you see these are the predictions by the model. And over here, what we want to do is, let's say these are boxes that are generated. Now you want to generate a cumulative report. So that means on the whole data set, how many like specific category of animals were detected, and if there are any other parameters that are relevant, like if we have, let's say, a gold standard data set, if we want to evaluate, okay, that these are how would it perform? So this generate. So, all right. So this generate report module, which is out there. So this runs very quickly, just it's because it is not running any processing in the background. All it does is it just take those predictions by the module and just like then run a cumulative analysis on the whole data set. And that too only on the predictions. It has got nothing to do with the images now.
So Satish, just one question on that last slide.
Mhm.
So on that last slide, you have a number of individuals that were identified in different colors.
So that is because we are using a YOLO model in background, and those were a few of the incorrect predictions over there. So
Okay, and then there's a sheep in the middle that's no.
that was not detected yet.
Okay.
So yeah, so over here, I'm going to come to that further too. So whatever this AI module that we are using, what is actually happening in the backend, what we are using to do that. So this is a sample like though these all were sheeps and like shorts category, and it actually the model, the analysis that we ran, it like detected many of them like wrong too. So next part on which like Connor did spend like an extensive amount of time. So building and integrating this inside BIS. So over here till now, what we did was you have your data set, you upload it inside BIS, you can annotate it inside BIS, you can visualize it, you can edit the annotation if someone else have done it. You can also import the annotations if they are being done somewhere else, like through CVAT or in as like VGG, image annotator, VIA tools. So, and you can like, and then if there is no annotation, then you can actually run analysis inside Abyss. And that was the part where you can run a detection on a pre-trained modules. What if you have a new data set, let's say, and there are until now, like you whatever you have done, all that like I mean previous data set that have classes only like elephant, buffaloes, and wildebeest only. Now let's assume there are two more classes. There's like shorts also, and there is impala too, and you want to train another AI model for it. So that capability is, it is an initial stage inside BISC, but like we do have a proof of concept and we got it working inside BISC too. So with this, you can actually train your own AI model all inside this. You don't have to go and build a new architecture. You don't need to know any like intricacies of deep learning to how to actually like train a new AI module. So in this one, all you have to do is we're gonna show you a demo of this one to you also. So all you have to do is you select your data set, and then another bunch of training parameters that are needed. For example, how long you want to train it, and if you want to use like train it from scratch, and by scratch it means without any prior knowledge, the model is like completely random. Or if you want to train on top of a pre-trained model, let's say you had only trained on elephant, buffaloes, and cows, and you just want to, and that model was doing pretty good, and you just want to add two more classes, and it makes it like so that starts recognizing those two. So that can be done inside BISC too, with a very simple interface and with few drop downs, and you can try and train your own model. So this is like a kind of like bringing a human in the loop. So what is like, you take the BISC UI, you upload your all images, then you run a detection on those, and then a human actually goes. So let's say the model, whatever training has done and whatever output it generated, for example, in the previous image, there were all of them were shorts, but it actually detected wrong categories, and few of them it didn't detect. So you go and you manually correct them, and you again hit retrain. So the model will again start learning based on those correction. So it's like you bring a human inside the loop and you complete the loop. So this can so that is also possible inside this. So now going on to the part, so now is the I'm going to talk a little bit about what is happening behind the scenes, and that is what actually is the AI module and the one which we have been building. So any questions so far based on on the BISC side?